The next question is similar to the previous one. Here the equation given to us is as 3p plus 1 x squared plus 2 times p plus 1 x plus p equal to 0. Okay, here again the roots are real and equal, so the same equation that we are going to solve is discriminant equal to 0, that is b square minus 4ac equal to 0. I want everyone to pause this video, give this question a try, and then watch my solution. Okay, so I'll just write down the question first. We have 3p plus 1 x squared plus 2 bracket p plus 1x plus p equal to 0. Okay, now if we compare this with the standard form of quadratic equation, the value of a that we will get is 3p plus 1. Yes, the first whole bracket is the value of a. Okay, similarly b is equal to 2 bracket p plus 1. Yes, this whole thing is b. This whole thing, that is x, the coefficient of x will be considered as b. And what is the value of c? The value of c here is p. Okay, now since the roots are real and equal, since the roots are real and equal, discriminant should be equal to 0. Okay, so which equation we are solving here? B square minus 4ac is equal to 0. Okay, so let's substitute the values of a, b, c in this equation and check what do we get. So we get 2 bracket p plus 1 whole squared, 2 bracket p plus 1 whole squared minus, from here we will get 4 times a, the value of a is 3p plus 1 times p equal to 0. Okay, so this is the equation we are getting. Now in the first term the square will be distributed and this will become 4 bracket p plus 1 whole squared minus 4 bracket 3p plus 1 into p equals 0. Okay, what we are going to do here, as I can see that in the two terms 4 is common, so we will take 4 common and transpose it to the right hand side. Okay, so what I'm going to do is I'm just going to make a line here so that we don't get confused. Okay, so we will take 4 common. Now when we take 4 common, in the bracket that we'll be left with will be p plus 1 whole squared minus 3p plus 1 into p. Okay, and this equals to 0. Now we can transpose the 4 to the right hand side and 0 upon 4 will become 0. So what we are getting, p plus 1 whole squared minus 3p plus 1 into p equal to 0. Now we can expand the bracket using identity. So p plus 1 whole square will get p square plus 1 plus 2p. We'll multiply the p inside the bracket and we'll get minus 3p square minus p equal to 0. Okay, so we have p square and minus 3p square as the like terms, 2p and minus p as the like terms. P square minus 3p square will become minus 2p square plus 2p minus p will become plus p plus 1 equal to 0. Okay, so this is the equation that we are getting. From here we will, let's say, multiply the whole equation by minus 1. Okay, why we are doing that? Because we always want the first term here to be positive, okay, so we'll take minus sign common. What we will be left with, 2p square minus p minus 1 equal to 0. 2p square minus p minus 1 equal to 0, and hence the equation has become 2p square minus p minus 1 equal to 0. Okay, so from this, on solving this, we have got a new quadratic equation. Okay, a new quadratic equation has been generated. Okay, so basically we need to solve this, or we can say we need to factorize this equation and find out the value of p. Okay, so how can we factorize this? We will get here 2p square minus 2p plus p minus 1 equal to 0. I hope everyone remembers the topic factorization done in class 9. Okay, so what I have done here, I've used the method splitting the middle term to factorize this equation given. Okay, so now we can group the first two terms and the last two terms. Okay, on grouping the first two terms, we get p common, or rather 2p common, and in bracket we'll be left with p minus 1. From the second group, we can say we have plus 1 common and we'll get p minus 1. Okay, so now from this group we can take p minus 1 common, and in the second bracket we'll be left with 2p plus 1. Okay, so we have p minus 1 in the first bracket, second bracket we have 2p plus 1 equal to 0. Now whenever the product of two factors is 0 or two numbers is 0, one of them, at least one of them, should be 0. So from here what do we conclude? P minus 1 is 0, or the second bracket 2p plus 1 is 0. From here we get the value of p equal to 1 or p equal to minus 1 by 2. Okay, so these are the two values of p. These are the two values of p. Okay, I hope everyone understood this. Kindly note this down.